Welcome to the deep dive. Today, we're plunging into something pretty fascinating. This whole tension we feel, right? We love what AI can do, but we're also, really concerned about our privacy.
It's a huge challenge.
Exactly. And Apple thinks they might have cracked it, or at least taken a big swing, with something called private cloud compute. PTC, they call it.
Right.
So our deep dive today is really about digging into that claim. Can Apple actually deliver powerful AI features without, peeking at your personal data? We want to look at the tech they're using and figure out what it all means, maybe what the rest of us can learn from it, even if we're not using Apple stuff.
Precisely.
And yeah, it's worth mentioning where a lot of this insight comes from. It's based on a pretty detailed analysis by someone with a PhD in data science, background in AI, and cybersecurity.
Okay.
But crucially, they figured this out just from public information, Apple's own papers, tech talks, that kind of thing. So it's an unofficial view, but a really informed one. Got it. Okay, so let's set the scene a bit. Privacy concerns, especially with AI, they're not exactly new, but they feel really urgent now.
Definitely.
We keep seeing these massive data leaks in the news. I mean, remember that DeepSeek incident? Something like 100 million sensitive chat logs just out there?
Yeah, that was bad. It really makes you think twice.
It does. And it makes you wonder about the tools you use every day.
Like ChatGPT, for example. Lots of us use it. And you might think, okay, I'll just turn on private mode. Or maybe use the API that says zero data retention.
Right. Sounds safe enough.
Well, yeah, except recently it came out that OpenAI actually has to keep that data anyway, regardless of those settings. It just shows how hard it is to really trust that your data isn't being kept or looked at when it leaves your device.
So that's the kind of nightmare headline Apple absolutely wants to avoid, isn't it?
Totally. For Apple, privacy isn't just a feature. It's like core to their brand. It's a massive selling point. They need people to trust them on this.
So avoiding those breaches is kind of fundamental to their whole business model.
Exactly. And the fundamental problem they're tackling is, well, the really cool AI stuff, the big models, they need way more power than your phone has.
Right. You can't run GPT-4 locally on an iPhone. Not really.
Not yet, anyway. So you have to send data to a server somewhere.
Right.
But the second your data leaves your phone, its privacy is, inherently less secure.
Okay.
So the big question Apple asked is, how can we get that powerful remote AI compute, but make it genuinely private and somehow affordable to run at scale?
Because usually sending data off is, like you said, throwing it into a black box. You just hope for the best.
Pretty much. You send it off, something happens on a server you can't see, and you get a result back. You have zero visibility or control.
So Apple's goal with PCC is to somehow make that box not quite so black. Maybe give your iPhone some insight, some control over what happens.
That's a good way to put it. They started by setting some really, really strict rules for themselves, foundational requirements for how this whole system must work.
Okay, what are those?
There are 5 key ones. First up is stateless computation. This basically means the server only uses your data for the immediate task. It can't log it, it can't store it, it can't build a profile on you over time. Each request is treated as totally separate.
So no memory of past interactions.
None. Second, and this is crucial, enforceable guarantees. The privacy rules aren't just policies people are supposed to follow. They're baked into the system's code and architecture.
So like you mentioned before, no SSH means there literally isn't an SSH service running for anyone to connect to.
Exactly that. Or don't save things means there's literally no disk drive configured for that AI process to write to. It's technically impossible, not just against the rules.
That's a big difference. Okay, what's third?
Third is non-targetability. The idea here is that if someone, an attacker, wanted to find your specific data, they couldn't easily pick you out. They'd have to somehow grab everyone's data flowing through the system and try to sift through it all, which is way harder.
Makes sense. Less chance of being singled out.
Fourth, no privileged runtime access. Basically, once the system is running in production, there's no backdoor, no special access for anyone, not even Apple engineers, to bypass the privacy protections.
Wow, okay. That sounds pretty locked down.
And the fifth one, maybe the most important, is verifiable transparency. The system has to be able to prove to your device and potentially to outside auditors that all those other guarantees are actually being met.
Okay, hold on. If it's stateless, no one can SSH in, no privileged access. How does Apple even know if things are working? Like, how do they debug? Or even know if an AI feature is popular? Doesn't that make it impossible for them to manage?
That is an excellent question, and you hit on one of the big trade-offs. We'll definitely circle back to the operational headaches this must cause.
Okay.
But the short answer for now is they rely on aggregated, anonymous data for that kind of thing. They deliberately sacrifice detailed operational insight for privacy.
Fascinating. That's a serious commitment. Okay, so given those incredibly strict rules, how on earth do they actually build something like this? What's the tech that makes it work?
Conceptually, a few key ideas. First, there's this anonymizer layer. The system is designed so that when your request hits Apple's servers, they can't directly tell it's you.
Hides your identity somehow.
Yeah, it makes it harder to link the request back to a specific user. And related to that is how they handle, the login process. They essentially separate your identity check from the actual AI request.
How does that work?
Think of it like an old arcade.
Yeah.
You put your real money in a machine and get generic anonymous tokens, right?
Yeah.
Apple uses something similar cryptographically, involving blind signatures. Your device proves it's you to get a sort of anonymous coin or token, but then it spends that token to get the AI processing done without Apple linking that specific processing request back to your Apple ID. They just see a valid token being used.
Okay, that's clever. Anonymous arcade tokens for AI. I like it.
Yeah, yeah. And then to achieve that verifiable transparency, two bits of tech are really central. First is remote attestation.
Right, you mentioned that. How does it work?
Okay, so your iPhone basically challenges the remote server. It says, prove to me what code you're running right now.
Like a security check.
Exactly. The server responds with these things called signed claims. It's cryptographic proof saying, I'm running on genuine Apple hardware with this specific secure OS version, this specific bootloader, and so on.
Yeah.
It also sends a public key.
Okay.
Your iPhone checks all that cryptographic proof. If it all looks good, if it trusts the code the server claims to be running, then it encrypts your actual request data using the server's public key.
So the server can only read the data if.
If and only if it's still running that exact same trustworthy code it attested to. If the code changes, it loses the ability to decrypt. It turns the black box kind of translucent. Your phone gets a guarantee before sending sensitive data.
Wow. Okay, that is pretty cool. What's the second piece?
The second piece is the transparency log. This is simpler conceptually. It's just a public, append-only database like a list that things can only be added to,
Right.
never changed or deleted.
What gets added?
Every piece of software, every binary that Apple approves to run on these private compute nodes. Each entry is signed, saying basically, Bob from Apple Security approved this specific version of the AI model on November 1st.
Okay, so it's a public record of all the allowed software. How does that help me as a user?
Three main ways. One, security researchers can download these publicly logged binaries and analyze them offline to check they do what Apple says they do, builds public trust.
Right.
Two, your iPhone can check the claims it gets from remote attestation against this public log. It confirms the server isn't just running some code, but code that's actually on the approved list.
Verifies it's legit.
Exactly. And third, and this is the big one for security, if your phone ever gets an attestation for code that isn't in the public log,
Uh-oh.
bingo. You know immediately something is wrong, the system's likely been compromised. It's a powerful detection mechanism.
So attestation proves what is running. The log proves it's allowed to run.
You got it. And quickly, other pieces fit in here too. Oblivious HTTP is used for that anonymizer part, routing requests, through a proxy like Cloudflare, so Apple doesn't see your real IP address.
Adds another layer of separation.
Yep. Then there's the secure enclave on your iPhone or Mac that's special hardware for securely managing cryptographic keys, like a hardware vault.
Like TPMs and PCs.
Very similar idea, yeah. Provides a hardware root of trust. And finally, secure boot and a hardened OS on the server nodes themselves. They run a stripped-down, super locked-down version of iOS, making it really hard to tamper with.
Okay, this is a lot. It sounds incredibly complex and, well, impressive. But nothing's perfect, right?
Yeah.
What are the downsides? What are the trade-offs Apple had to make here?
Oh, definitely trade-offs. The biggest one, arguably, is you still have to fundamentally trust Apple.
How so?
You're trusting them to manage their keys securely, to run their supply chain securely, to build that hardware enclave properly. The trust shifts from maybe random third parties to Apple itself, but it doesn't vanish.
Right, you're betting on Apple's competence and intentions.
Pretty much. Another big one is limited availability. Right now, this PCC stuff is only for Apple's own features on Apple devices. Third-party developers can't just plug into this private cloud for their apps.
So it's a closed garden feature, for now at least.
For now, yeah. Then there's latency. While they try to do stuff on your device first, if a request has to go to the cloud, there's going to be some delay. Maybe not huge, but potentially noticeable for real-time stuff.
Makes sense. Sending data always takes time.
And the compute cost must be higher for Apple. All those layers of cryptography you mentioned, up to 6 layers before the data even hits the AI model.
That's a lot of encrypting and decrypting.
It adds overhead, definitely.
Okay.
Which also links to the fact that there are no custom models or fine-tuning. You can't tweak these models yourself because the whole environment is so locked down for security and attestation.
So you get the standard Apple model, take it or leave it.
Essentially. And think about client complexity. Your iPhone isn't just sending a simple web request. It's doing all this attestation checking, transparency log lookups, complex encryption. Your phone is doing a lot more work.
Right, the smarts are distributed.
And then there's the point you raised earlier. Operational challenges for Apple. No SSH, limited logging, debugging problems, or even just managing the servers must be significantly harder for their own teams.
Yeah, I can only imagine the runbooks for that.
And finally, because of the core privacy design, there's no detailed usage tracking. They can't easily see exactly how you are using a feature, which makes things like usage-based billing or fine-grained fraud detection really difficult because tracking that would undermine the anonymity.
So lots of benefits, but also some real constraints and costs baked in.
Absolutely. It's a specific set of design choices with clear consequences.
Okay, so this is Apple's approach, but what about the rest of the world? If you're not all in on Apple, what can the broader tech community learn? Are there similar tools or techniques available to achieve this kind of privacy elsewhere?
Yeah, definitely. This is one of the exciting things. While Apple put it all together in a very specific way, many of the underlying components have parallels or open alternatives.
Like what?
Well, oblivious HTTP and the concepts behind blind signatures, there are open source libraries and standards for those. For the hardware trust, we don't have the secure enclave exactly, but trusted platform modules, TPMs, are standard in most modern Intel and AMD chips.
Right, those have been around for a while.
And cloud providers are offering virtual TPMs too. Remote attestation is also often tied to TPM capabilities, letting systems prove their state, though maybe the standards aren't quite as mature or integrated as Apple's specific implementation yet.
Okay, so hardware trust and proving system state are possible outside Apple.
Yes. And for transparency logs, there are open source projects like SigSum and SigStore aiming to do very similar things, creating verifiable logs of software artifacts.
So others can build similar audit trails.
Exactly. And a really big development is confidential VMs in the cloud. Google, Azure, AWS are offering virtual machines, now even with powerful GPUs like NVIDIA H100s, that encrypt their memory while in use.
Whoa, encrypting RAM.
Yeah. It means even someone with physical access to the server or the cloud provider themselves theoretically can't just dump the memory and see your sensitive data while it's being processed by the AI. That's huge.
It really is a big deal for cloud privacy.
And one advantage many non-Apple solutions can have is open source and reproducible builds. If the server software is open source, researchers can review the source code directly. And if builds are reproducible, you can verify that the binary running on the server actually matches that reviewed source code. That builds a different kind of trust.
Right, transparency through openness rather than just Apple's attestation.
A different approach, yeah.
So it definitely sounds like Apple has raised the bar, pushed things forward, but the wider industry is moving in this direction too.
Absolutely. The market is responding. You mentioned Azure AI doing private inferencing. Meta recently announced something for processing WhatsApp data that sounds remarkably similar conceptually to PCC.
Even WhatsApp needs to avoid those leaks, right?
Everyone does. The pressure for genuinely private AI processing is building across the board.
It feels like a real shift is happening.
I think so. What's really exciting is that this kind of private AI, it's not just a theoretical thing anymore. It's becoming a practical reality, being built and deployed now.
Which leaves us with a pretty big thought, doesn't it? As AI gets woven deeper into everything we do, what does this whole shift towards private by design really mean for us? How might it change what we expect from tech companies when it comes to trust? And maybe more personally, how might these kinds of innovations change how you, listening now, think about your own data and the services you decide to use?